Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about geothermal for future. So let's dive deep into it. So basically we need a non-polluting power source, and it would be great if it can work 24 into 7 into 3. Basically a nuclear system without the nuclear waste or the hassle or the boom events. So basically geothermal is that. Why? The core of the earth has a lot of radioactive decay, more than enough heat. So we good. It's like might as well use it, and it does meet that problem. Like people say now, why work on fusion when you have fusion on above your head? This is same. Why work on nuclear when it is below your legs? So 24 into 7 into 365. So geothermal meets that goal. However, it's rare. As in right now, if you want geothermal energy, most of our power plants are, oh, we found a hot spring there. Let's drill and make a power plant out of it. So what if humanity changes the perspective? Instead of like, hey, we have a hot spring there, let's just drill, to let's make what we are looking for. So right now our philosophy is look for it. What if we make it? So there are a few companies that are trying it. I have covered two. This will be the second company. First company I have covered is Quasar. This puppy is basically using the fusion technology of basically igniter. They're like, okay, what if that millimeter wave igniter can be utilized for drilling? And yes, it can drill through directly. So they are trying to aim to drill kilometers deep, like 7 to 8 or maybe even 12 kilometer. So if they can go that deep, they will get more than enough heat energy anywhere on the planet. Let them be anywhere on the planet that they're good. They're good. They got this. No problem. But it is a very unproven, untested technology. I am in touch with them, like as in the actual people, and I am even in touch with the one of the investors. So it is taking its sweet time. So, but again, it's a very new risky approach. Somebody has a different approach, which is Fervo Energy. Fervo Energy has a different idea. It's like, hey, we have oil and gas industry that figured out horizontal drilling. Now it's an ancient technology, like so ancient, like Iraq or Kuwait war started over that. Iraq was saying Kuwait was horizontally drilling and leaching all the oil. So that's how basically Iraq justified Kuwait boom boom. So after that they got kaboomed, but such is life. So this technology that you drill like this and then you go Tokyo drift 90-degree, yeah, that's a done technology. So this company, basically Fervo Energy, they are doing the same thing. Oil and gas industry already created this technology. It's not new. It's been there for at least 50 years. We good. We got this. So Fervo Energy, the idea is they're gonna copy paste technology from oil and gas industry. They're not gonna reinvent something or build something new. It's just we have it, Control C, Control V. Horizontal drilling and hydraulic fracking, that's their key element, meaning go into the hot rocks, which could be as low as 2 kilometers to 3 kilometers depth. Go into those hot rocks, drill horizontally, basically reach that depth, drill horizontally, and then crack it. Once you have cracked it, now that becomes what you call enhanced geothermal system. Basically you are making your well rather than acquiring it from nature, like, oh, it's here, you drill it here. No, anywhere. That's what enhanced geothermal, because again, it's all about depth or enough surface area to collect useful heat. Because all places, even if you go as low as like 2 kilometers, heat is there. It's just not high gradient enough or too expensive to reach. And what is their USP? If all it took is like oil and gas industry, can't those companies start their own stuff? Yes, they can. But this is their special sauce. Fiber distributed acoustic sensing, meaning they have this fiber, and this fiber could be as long as their bore well, which could be 12 kilometers, meaning again, not 12 kilometers deep, like 3 to 4 kilometers like this, and then multiple kilometers that way, and they're gonna have this fiber. Now this fiber, every meter, it has a node. That node is sensitive to vibration. Basically, you send a laser pulse, and laser pulse is reflected backwards from those nodes, and each node, based on time of flight, if it came back 1 second, it's 1 meter. If it came back 2 seconds, it's 2 meter. Again, it's not second, nanosecond, but you get the point. So based on time of flight, you can count each of the nodes, basically pulse from nodes. Each node is analyzed because return of it is directly proportional to the vibration. Meaning, if a node is returning, like you sent a, let's just say green, and node returned it red, now you know that node is vibrating, and you have the whole pipeline sorted, like the whole bore well, you have that resolution, 1 meter. That is very high resolution. And you're like, what can you figure out? Well, a lot. Like how hard is the rock, how rocks are behaving. When you're drilling, you're imparting physical shocks to it. You're going boom, 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 boom. And that shock is traveling through it. And how it's traveling, that tells you how hot it is, how it's plastic it is, everything. So that's your like what we call distributed acoustic pressure sensing. It will figure out fluid flow, because again fluid fights with you if you're like blah, 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 doing it to it. Vibration, pressure waves, all of those things create a data packet for you, where it's like, okay, what is actually happening, not just theoretical model, like what is actually happening. On top of that, they also have second version of this, distributed fiber temperature sensing, similar technology, but I do not know how. They say it's a Rayleigh scattering, where node is changing the wavelength based on the temperature. It works apparently, and it's a known thing, and some people have even created fibers that are 100-kilometer long and use it under undersea fiber, and they can monitor the temperature for 100 kilometer without optical boosters. So these technology, basically having this sort of optical fiber going behind the well, gives them a very voluminous data. It's not just there's a pipe, it's like there's a pipe and this is the heat flux, this is the vibrational characteristic. That gives them a more complete three-dimensional photo. So they have a exploration well. That well gives them enough data that next exploration well would be far more tuned. These two builds up, because of these data strings, they are able to build up a much more complete understanding, and voila, they can fine tune. Basically first two will be exploration, after that they're like, we got this, man, we understand how this area is behaving and we can handle this situation. So that's the their special sauce, basically not just drilling that you can buy, like you can buy the drilling machine, but having this all this integrated, that's the hard part. Now the working of it is very simple. They're drilled to 2 to 5 kilometer. Again, I don't think they have yet to drill to 5 kilometer, but they can. Again, that technology is sorted. It's normal for oil well. Land-based oil wells can go that deep. It's good, sorted. The hot rocks, the moment they reach hot rocks, they become perpendicular. So that's where they're becoming hot rocks. And these hot rocks, they are cracking via water and some special sauce, let's call it rock. So they have a rock and basically water, very high pressure, and they have perforated tube. Basically the moment they go horizontal, they start to install tubes that are perforated, as in it has holes. So that holes allows high pressure water that you're on ground, you're so you're doing that, it goes here, it gets coupled here. Now there are multiple things helping it. First, high temperature, as in the water will become flash steam instantaneously. So that creates enough pressure that will cracks the rock, and the aggregate that you are sending, that aggregate gets force fed into those cracks and does not allow the crack to seal again, because again at this sort of temperature and pressure, rocks are more like plastic, where it's like it will just collapse. So that's why, like, you don't just use water, you always use water plus sand. Like these are generally used for oil and gas well specifically, because sand becomes a permeable what you call crack, which gas can leak through. So here they are doing the same thing. They're gonna feed water, so the rocks are acting as a scaffolding and creating a pathway where heat can go in and out, and heat in this scenario is water. So keeps the rock open so fluid can boil. And again, be mindful, it's a very complex system, meaning they go drill like this, then turn, and then go. They can pull back, turn again, pull back. They can literally go 360 degree on the same depth well. So again, let's just say the yield is not reaching what they are expecting. They can do exploration, and because they have sensors throughout the system, they can be like, we reach the heat point. Or if, like, let's just say they found and it's a cold pocket, they can be like, okay, let's not waste time here, let's divert it. So that's how they drill it and then crack it, and then they have another drill on top of it. So bottom one is your input, upper one is the output. So you put high pressure water in the input part, and output is the hot pressure, and voila, that it boils, it travels upwards. Again, it's unlikely that it completely converts to steam, because you may not want that. So you may pressurize the system so it does, while it is looping the heat, it's not doing phase change. It depends on the pressure and all that, how hot these things are. And generally they are only talking about like 200 degrees Celsius, not super duper high temperature. And multiple well format, because again, even if you go there, you can. So basically it's almost like how you have keyhole surgery in human body, it's same thing. You're drilling one, and once you can do that, you can like create a net, and the bigger the net, the more extraction efficiency you get. And the water that is circulating in this while running operation is called brackish water. That's the working fluid. And they are also using polycrystalline diamond drill bits. Now be mindful, when you are comparing their approach to other oil and gas people, it's a bit different. Why? Oil and gas people are gonna make money when oil and gas is coming out. They cannot do that. They have to make money on something that is getting cheaper day by day, as in electricity, kilowatt hour, those are getting cheaper day by day. So they have to do reduce the capital investment. The best place, the most hungriest part is not the basically heat to electricity. That's the cheap part. Drilling is the expensive part. So they are working completely different ways. Like, okay, how can we reduce the drilling part? Because again, if it takes 2 years to drill versus 1 year to drill, even if you are using diamond, like actually polycrystalline diamonds, it's free for you. Time is the most expensive asset for them. So they are optimizing everything. And again, those fiber systems are not like unheard of. They were not even invented for them. But they are not used too often because it's expensive. They are like, no. If it allows us to save time, and like again, our first exploration well becomes 10 times more yieldful, as in like, hey, this is exactly where you have to go. Shut up, take money. So they are changing the dynamic in terms of tools are same, but how they are utilized is different. They are optimizing on get it done as quickly as possible because that's their primary expenditure. Everything else is sorted. So that's their working. That's why they are literally using diamond, like actual hardcore diamond. Now we come to the plant, as in this is the drill puppy, this is the actual heat to electricity puppy. So they are using binary cycle. Now why would you want to use binary cycle? It seals the environment, meaning the hot water is going through that perforated tubes, that's still there by the way. So that perforated tube is your input and you extract from the perforated tube that is above it. So you have a complete loop. Because it's not exposed to the environment, it does not leak anything, which could include mercury, sulfur, stuff, uranium, methane, those sort of things. So you do not want to expose it. And everything remains sealed so that your water consumption goes down drastically. So this is the brackish water cycle that is completely isolated from environment. And then that runs your heat exchanger. How do you cool the heat exchanger? You run organic Rankine cycle. This machines that you are seeing is turbo machinery that is classified as ORC. I have made dedicated video about ORC. Why ORC? Because ORC work at very low temperature. Steam is really good, really efficient, but it will not even start at this sort of low temperature unless you do some very painful things. While ORC is like, I'm good. Like ORC is like, it can work as low T delta as like 15 degrees C. Here you have 150 degrees C T delta, so it's good, it's got this. So organic Rankine cycle is the system, and they are using a radiator that is air cooled. There is no water spraying on the radiator. There is only one plant in India that does air cooled coal power plant. There are 1 or 2, if I'm not mistaken, in USA. Some are in European Union, where the coal power plant, instead of drinking river dry or groundwater dry, they have like air cooled radiator. It's huge. You will be freaked out if you ever saw one of them in person. It's huge. Like each of the fan blade is size of a helicopter. It's huge. India has one in Jharkhand, in Karnapur. It's huge. Like I want to pilgrimage there. That's how scary big it is. So they are using that. And why can they do that? Well, I looked into it and people were like, oh, it's so hot area. Yeah, it's Milford, Utah, USA, and they have very hot temperature. Like how can they survive that? 35 degrees Celsius is their hot temperature and their cold goes to 5 degrees Celsius. I understand why Japanese people were screaming that 27 degrees Celsius was hot. I'm like, if most of your months were like barely 5 to 10 degrees Celsius, of course you're gonna scream at 27, even though my AC is set at 27. So that's why they can run it efficiently. And ORC is not efficient. It does work. That's the good part. Bad part, it's not efficient. You're only gonna get 5 to 10% efficiency. So cold reservoir efficiency is directly proportional, meaning the cooler this part gets, more better for you. Their plant size is 500 megawatt E. They have already completed 100 megawatt. Basically, they are going to do it in 3 phases. First 100 megawatt is already done. The second one is being done at this time. Everything is sorted, as in like they are selling electricity. It's done. I'm not talking about a company that would. No, it's done. They already had a pilot. This is the delivery, and they're surprisingly decent on schedule. So basically your heat source, this is the heat source, you dump the heat, it evaporates the refrigerant, propane and butane mix that runs your turbine, gives you electricity, then it goes to the condenser unit dumps the heat into the ambient, pumps, cycles it again, and everything continues. A pump could be in the same shaft as an expander, most likely, that we call turbo expander. So this is the plant side of things. And again, this is sorted. Like all the heat exchanger, like it might sound complex, Brian, it's very simple. A shell and tube heat exchanger. Nothing in this is complex. Like you can just pick up the phone, hey, Mitsubishi Heavy Industry, give me some this. They have their own sub company. I keep forgetting the name. That's the plant that gives organic Rankine cycle. It's Mitsubishi's subsidiary, I think, which they are contracted with. So it's like a, pick up a phone, order it, you're gonna get it in 2-3 days. So it's a sorted thing. Now, question becomes how India can utilize it. Now, one thing you have to understand, every time humanity messed up, it always had one thing behind it, is one tool to rule them all, like, one ring to rule them all. Yeah, that will never ever happen, ever. Like, we have to use the right tool for a right job. For example, imagine your body. Why does it have so many organs? Because each organ is optimized for one thing. For example, I keep saying solar is great. Do I say that run a national grid on solar only? Hell no, it is not good for that. Mix it with wind. Again, still half good. Mix it with biogas. Mix it with geothermal. Mix it with hydro. Mix it with other things. Voila. So then it becomes a resilient, stable, cost-effective, cheap and abundant part of it, ta-da, without any sort of penalty. Or again, minimal penalty. That's the most practical part of saying it. Minimal penalty. Basically, you do not want to amplify the feedback loop that we are going through. You want to minimize it. That's the easiest way of doing it. Right tool for the right job. So we can utilize this technology, geothermal drilling and energy extraction, for cooling our cities. India is hot. It's getting hotter. So the heat you get out of basically those sort of geothermal well, it's what we classify as low-grade industrial heat, 200 degrees Celsius. Some use of it, but not that effective. However, if you convert it into electricity via ORC, you do not have to worry about it because you are not paying for it's not like you are burning coal. It's not there. So, and again, it's 24/7. So even if it's not a GG pipeline, you still do not have to worry about it. But 5 to 10%, it's very difficult. And not to mention, I'm assuming it will not even be 5% if the outdoor temperature is 65, which is Wednesday for India. So that's why I talked about that temperature out there. And like the average temperature is 10 degrees Celsius. Like there is only one peak that I saw that touched maximum. I'm giving a maximum 35 degrees Celsius. I'm like, of course the ORC is working that well here, but here it won't. However, we can have a same basically drill plant and have a small, like few megawatts. But we can directly run absorption chiller on that because it's 200 degrees Celsius around temperature. That's perfect for absorption chiller. Absorption chiller can easily work as low as 90 degrees Celsius, and 120 they're flying. They're like, we good, brother, we good. So we can use that, and coefficient of performance would be lower, not because of the chiller or heat source, because again India is hot, as in the cold reservoir is not that cold, and again I'm not comfortable with a boiling water away. If you have a river and rich supply of water, okay, but again still not comfortable. So in those sort of scenarios, you're still gonna get 0.6 COP. But here's the deal, you have so much heat 24/7, 0.6 COP is magnificently huge. Magnificent, like that 500 megawatt, that's a very small portion of the heat flux. So if you take the whole heat flux and convert 60% of it into cooling, as in like it's gonna leach away 60% of heat with it when it's going out via absorption chiller, yeah, that's like shut up, take money. That's district cooling. Like you're gonna cool down every massive building in Delhi, capital of India, which is running on these chillers, so to say. So hospitals, massive hotels, office buildings, basically big energy consumers and water consumer, you can just like shut them up. It's like, bro, your energy consumption instead of multi-megawatt will become few megawatt. Like you're not consuming hundreds, hundreds of liter per hour to few. We can do that, district cooling. Again, India is a bit behind in this, but sooner or later we're gonna get there either via bitch slap or our wisdom. We're gonna get there one way or the other. And this is India's first district cooling plant experiment. This is next to Ahmedabad. It's called Gifticity. We're trying that. Now be mindful, Ahmedabad is hot. It's hot. So they're using that. But again, this is a multi-megawatt consumption puppy. Like, what's the point if you're dumping multi-megawatt? Multi-megawatt here, per ton conversion is much higher compared to each of these buildings doing that. So if you look into tonnage to megawatt consumption, doing this is far more efficient. Now imagine doing the same thing without consuming electricity. You have the drill system, you have a small ORC plant, because again, these, while they do run, the primary workforce is heat itself, it does require some plumbing, as in like hundreds of ton unit does have like 1 or 2 kilowatts of pumps. So you do require some energy. So again, that's why I said like some small amount of ORC would be there, and that will circulate the fluid. And what is this so-called fluid? Water and lithium bromide. And lithium bromide is a salt. You don't need anything more than that. And by the way, the COP I'm taking, the worst case scenario, if people have said like there are better systems. Again, if you're doing something like this, you will use a better system, which could be dual stage absorption chiller that can easily reach 1.2 COP. At that point in time, this would be like, bro, we have so much free cooling that you were just like, don't worry about it. So this way we can save money, which matters the most, and we can save environment, which matters the most to our future. Both survives. Again, not trying to get electricity out of it. We can. It's just not that useful, because what will you do the first thing with that electricity? Yeah, run cooler or AC. Might as well directly get cooling. So that's the whole point I keep talking about, like a right tool for the right job. We can get electricity via solar, like we could, but again, solar will not give you so much power that you can run AC 24/7. This will run your AC 24/7. Now your battery requirement goes from multi-kilowatt, multi-unit battery, as in like 10 to 15 unit for a small house, to 2. We good, sir, we good. So this is the easiest way of taking care of. And another thing you can also do, for example, big cities, they also have industry nearby. Industries, many times they require medium grade heat, which is below 500 degrees Celsius. You can achieve 500 degrees Celsius heat via heat pump, but it does require hot to be hot. We have hot, gigawatt of hot. We good. Basically, we have one line for cooling, one line for heating. So if you have a building and you, for some reason, let's say for cooking requirements a lot, you need high heat, run your cascading heat pump with this, and you cannot cool it. Basically, we're gonna charge minimal amount of money. And again, why would they use that rather than directly air? Air is not stable. You want something stable. So for that reason, this is a much better system. So we get even money recovery from that side. Cooling side, we're gonna collect some money, and the source energy is free. So overall, it's economically wise and recycling the energy far more effectively. And in grander scheme of thing, planet does not change, because that heat is literally nuclear radioactive heat. It will decay, it will give off that heat, and it will go into a vacuum of space eventually. We are just increasing the speed a little bit, so it's not fundamentally different. So this is one very clever utilization for Indian condition. Indian hot environment, we can cool it. Although I don't think we can shrink it to do households. So this was my presentation on basically utilizing geothermal for the future. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me excitement. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.